Bismillahirrahmanirrahim. Today we have a discussion related to the example of the compound lottery. And in previous lecture, just recall or the recap of that lecture, we started to discussion related to the compound lottery and the simple lottery. And in case of the simple lottery, we found out, we concluded that now, for example, if individual toss a coin, so there is a equal chance to get a probability to head or tail and similarly. And but in some cases he is not interested to play a simple lottery or realize to play a simple lottery. He is interested to for a compound lottery. In that compound lottery we discussed that it is a linear combination of two separate lotteries, and that is called basically the convex combination as well as. And we finally concluded that for example, if there are two lotteries, L1 and or sorry, P and Q are two lotteries, two lotteries. So the compound lottery will be compound lottery will be uh, P alpha P plus 1 minus alpha Q, uh, subject to alpha belongs to 0 and 1. That is kind of the compound lottery. Okay. Now we have some numerical example related to the compound lottery. What is the numerical example? For example, let's say numerical example. Uh, a coin is tossed. Okay. There are two possibilities. There are two possibilities. Either head, that is H, and tail, that is T, right? And for example, we have two stage lottery, and one example is that if you have a simple lottery, stage 1 simple lottery, that if you have had got, for example, $100, that probability of had, that is PH equal to 50%. Clear? If you have had win $100, that probability of had, that is PH, is 50%. And it is called, for example, lottery A, we name it. And similarly, if you have had, there is possibility to win dollar 50, and again its probability is 50%. What does it mean? K, there are two possibilities. Either if you have had, so there is 50% chance to have dollar 100, and there is 50% chance to win dollar 50. Yeah, there are the two possibilities in case of lottery A. And for example, if you have a stage 2 and lottery B, in case of tail, yes, in case of tail, 25% chance to win dollar 100, and 50% chance to win dollar 50, and third, similarly 25% chance to win dollar 0. Clear? So now there are two lotteries. Either you have to decide to play lottery A or lottery B, or if you have had, so you decide to play lottery A. In that condition, the lottery A have two options. If there is the 50% possibility to get $100, or there is 50% probability to get $50 in case of head, if you decide to play lottery A in condition when you have head. Clear? Or when you have tail, so you decide to play lottery B. In that condition, 25% chance to win dollar 100, and 50% chance to win dollar 50, and similarly 25% chance to win dollar 0. So there are the possibilities. Now, uh, through these lotteries, we have to add the possibility or the probability of each lotteries with respect to its payoff. So what does it means? For example, K, in both lotteries, what is the probability of win $100? Okay, so we have to take the combination of these two lotteries, because the in case of the compound lotteries we add the all possible combinations. Clear? If you recall is that कि dollar यानी alpha p plus 1 minus alpha q. Clear? So for example, it is lottery 1, right? And this is your lottery 2. Clear? So there are the two lotteries A and B here. So in that condition, for example, let's say, so it means that is the probability to play lottery this one. Clear? Right? And that is the probability to play lottery Q. Clear? Now what we are doing that in both condition, for example, let's say through both lottery, let's say you have $100 to win through both lotteries. So what you need to do it, you need to multiply the probability of $100 through both lotteries plus the probability of play lottery A or lottery B, right? Clear? $100 की probability is that 50% in case of head, and there is what, if you play the lottery B, so there is 25% to play to get win $100, right? And what is the probability to play lottery A and lottery B? Lottery A has a probability 50% and similarly lottery B has a probability 50%. राइट क्योंकि देखो यही होगा ना कि नाउ यू हैव द इक्वल चांस ना एंड इन दैट कंडीशन either you will 50% chance you will play lottery A or 50% chance to you will play lottery B, but in both lottery there is the possibility to win $100. What, but their possibilities or the probabilities are different. In case of the lottery A, your probability to win $100 is 50%. In case of lottery B, your probability to win $100 is 25%. So we multiply with these probabilities and then sum up. Clear? So that will be the total outcome with respect to the $100. Okay, now look here. Okay, outcome $100 with lottery A and B, right? Outcome $100 with lottery A and B. Clear? So yes, what? So for example is, first of all, probability of lottery A multiply, yes, probability of had or the probability of $100, probability to win $100, right? Plus probability to lottery B multiply probability to win $100. Clear? So just plug the values here. 0.5 multiplies what? What is the probability is 0.5 in case of lottery A. Yes. If you had win, you have had, there is a 50% probability of had and you win $100. Sorry, you win $100. 50% probability to win $100. Clear? Now plus to play lottery B is zero point 0.5, and what is in case of lottery B to get $100 is 25%. So it means is 0.25. 0.25. So what you have at these values, zero point 0.5, zero point 0.5, 0.125 plus 0.375. 0.375, and you can write it approximately $37.5 if you have a linear combination of these two lotteries. So in case of $100, what is the linear combination? Through both combination of the lottery, you can win $37.5, or there is the probability is 0.35 0.7375. Clear? Now apply that conditions for outcome. Now what is the another outcome is? Another outcome is $50. The possibility to win $50. Okay? So outcome $50 here. Outcome $50. Yes. Okay. Again, probability of playing lottery A and probability to win $50 plus probability to play lottery B, and similarly probability to win $50. Yes. 0.5 multiplied by $50 probability in case of lottery 1 is 50% again. Okay, 0.5 plus, yes, in case of lottery B, you have again the 50%, right? So 0.5 multiplied by zero point 0.5. So what is the net answer is 0.5. 0.5, that is equals to $50. Okay, so now next is outcome. Yes, probability of A multiplied by probability to win. Yes, what? Probability to win 0. Yes, probability to win $0, and plus probability of lottery B multiplied by probability to win $0. So yes, so in case of lottery A, you don't have uh, the outcome of $0. Am I right? There is no possibilities if you decide to play lottery A in case of hand. So there is no possibilities of $0. Okay, as per our given condition. So now so it means ki 0. Okay, and this one is probability is what? Plus 0.5 multiply by is 0.25 plus multiply by 0.25. Yes, 0.125. Okay, that is equal to $12.5. Yes. So now we can conclude here. compound lottery is reduced form of simple lottery, that is outcome $100, probability is 0.375. Clear? And outcome $50, probability equal to 0 point is what? 0.5. And similarly outcome dollar is 0, probability 0.125. So what was your property of prospect? There was one important property of the prospect, that K equivalence standard prospect. Equivalence standard prospect we discuss as a property of prospect or the lottery. What does it mean? Ki there is one chance or the one probability which provides the same level of outcome, either at least equal to or greater than the lowest value, or same is at most or equal to less than or equal to the value which is upper bound of the income. Clear? If you recall is that in case of the equivalence prospect, we discussed that there is one possibility or the probability, for example, YU is upper income or highest level of outcome or highest value of outcome. Okay, and similarly YL is lowest value of outcome, right? So in case of, and the Y and the simple Y is a level of outcome, is a level of outcome at certain level of probability, level of probability that that satisfies, yes, what? Certain level of probability that satisfies U Y. Okay, we have discussed. Okay, there is one level of outcome at certain level of probability that will be at least, okay, at most equal to upper level of outcome or less than, okay, and that will be at least equal to the lower level of outcome. Clear? So same kind of thing you can apply here. That is the probability in case of the both lotteries. Either you decide to play lottery A or B, yani 0.375% probability to win a $100. Clear? That is the common probability that gives the same level of outcome. Either you decide to play lottery A or lottery B. And same kind of this one. In there is the 0.5%, yani 50% probability to win through both lotteries $50 outcome. And there is 0.125% probability to win $0 income in case of lottery A and lottery B, right? So these are the compound lotteries which reduce form of simple lottery and which satisfy that important axiom or the properties of prospect or lottery. Clear? Any question? Now next. Yes. Okay. Now there are some statistical notations. Some statistical notations. Some important stats, statistical notations. Okay. These statistical notations we will use in case of uncertainty, in the discussion of uncertainty. What are the some statistical notations? For example, probability distribution, case of discrete and continuous. Case of discrete and continuous. Probability distribution. This is distribution. Probability distribution, case of discrete and continuous. Now, uh, for example, suppose there are n numbers of finite State of the world. State of the world. STATE. States of the world. And now, so I can write this as equal to 1, 2, 3, and so on, n, finite set of states. Okay, I will discuss in detail why I'm assuming that the number of states are finite. Because one important thing is that whenever we will discuss the important nature of utility function, that is called the von Neumann and Morgenstern utility function and expected utility functions, or any kind of the utility functions, you have to assume the important assumption of the continuity. That's why in case of infinite set of state, we cannot prove the case of continuity. So that's why we are assuming here the sets of states are finites, not infinites. Clear? So we will discuss in detail when we will move towards the nature of utility function. Okay. Now, for example, so in that condition, um, and the probabilities of occurrence and the probabilities of occurrence, that is P1, P2, and Pn. These are the probabilities of occurrence P1, P2, and Pn. Now, these these probability distribution will satisfy will satisfy Pi, that is equal to 1 or one, and then fxi xi. Yeah. So in case of discrete, sum of all probabilities or the all lotteries or the probabilities will have equal to 1. Their aggregation or the summation will be equal to 1. So that is the case of discrete, and this is one the case of continuous. Okay. And what about this one? It is the PDF, probability density function. Fx is a PDF, Fxi is the PDF probability density function to select to select a random variable xi, clear, to select a random variable xi, or same like a probability in case of discrete function, or same like a probability in case of discrete function, clear. So same like a probability in case of discrete function. And one important thing, so it means that whenever the uncertainty is concerned, so in that we have to discuss first of all the case, the probability of selection or the realization of lottery, clear, or your random variables. You have to know about or realization of that probability or that lottery, clear. And second important thing is that how you will get a expected outcome subject to these probabilities, clear. So it means that you need to know about your expected value of outcome as well, that we have discussed in previous example of the compound lottery, that is your expected outcomes of $100 or $50 or $0, सही है, with certain level of assigned or realized level of probabilities with associated each value of outcome, clear. So it means कि you first of all you have to realize the probabilities, then you will decide कि which lottery you have to play, कौन सी lottery आपने play करनी है, then on the basis of that realization of the probabilities you will uh, expect certain level of expected outcomes, clear. So in that condition you have to define your outcome function, that is called expected utility or expected payoff function. Second, expectation. For outcome or payoff. Am I right? For outcome or payoff. Expectation for outcome, about outcome or payoff. So, what is your expectations to expected value? Here, xi or discrete. Sorry. So that is sorry, variance x fx and gamma x. Okay, so that is the case of continuous. That is the case of continuous. And second, you have to minimize your risk. Okay, because being a rational individual or the decision maker, first of all you have to realize probability or the chance of outcome. Second one is that expected value of your outcomes, and the third one is your minimization of your worst scenario. Okay, what may be the your worst scenario you may expect. Okay, if you lost or you lose someone, so what will be the worst scenario? So it means that you need to minimize your risk as well. So what, how you can minimize the risk? So it means कि variance of dispersion. Sorry. So variance or dispersion. Variance or dispersion to minimize your risk. To minimize risk. Okay. To minimize risk. Yes. What is the formula of variance of x? This one is pi. Discrete, and the continuous is yes, fx. X and the continuous. Okay. Sometimes we use this kind of functions in case of distributions that or sometime may use uh, that is the probability and minus number of number of outcomes square absolute value number of outcomes. So we can write this one, probability and number of outcomes. Or if, for example, in previous case, we let's say okay, we defined z is number of outcomes and small z represent probability of outcomes, right? So that was PZ. Okay, so that belongs to a space of lottery, if you recall it. In initial lecture we discussed that. Okay, that was the probability of outcome, and which belongs to the space of lottery LZ. Clear? And Z was the number of outcomes. So in that condition, this dispersion may be written as, this dispersion may be write as small z belongs to Z, and that is the probability minus 1 over Z number of outcome square. This is another form of the measure of dispersion, or to minimize the risk. Okay, so now let's start. Okay, example, suppose your decision maker decision maker wants to minimize his risk or dispersion uh, through through minimization of risk. Minimization of risk. Okay, so through different lotteries, so the measure of dispersion is, so measure of dispersion is this one. Z is the number of outcomes, and PZ is associated probability with that outcome. Okay. Now, for example, if there is uniformity among all lotteries, then decision maker preferred equally equally likely all lotteries. All lotteries. For example, P equal to 1 over 3, 1 over 3. What does it means? Let's say Z has A, B, and C. Three possible outcome. Set of three possible outcome. Z consists of set of three possible outcome. And in case of A, you have $1,000 to win. Clear? And in case of B, you have, for example, $10 to win, or in case of C, you have $0 to win. You got my point? Clear? And that is a lottery which have different associated probabilities for each level of outcome, or outcome belongs to set Z, right? So what is the probability in that lottery if you decide to play lottery P, that is the lottery P? So in that there are different probabilities which we have covered in compound and the simple lottery. K head has different probability to win. Clear? Similarly here the 1 over 3 possibility to win $1,000 in case of outcome A, and 1 over 3 to possibility to win $10 in case of outcome B, and similarly in case of outcome C you have same kind of the probability, so that is $0 or 1 over 3. So that kind of the lottery is called equally likely lottery. Clear? Or this event is called equally likely event, right? So that event is called equally likely event. Okay, so what is the dispersion in that case? We will, when you will have the equally likely event, so your dispersion will be zero and you will have no risk. Measure of dispersion, measure of dispersion, we will calculate later. The measure of dispersion, measure of dispersion will be zero. Measure of dispersion will be zero in case of equally likely event. That is means ke that value should be zero. Am I right? P z minus 1 over z square should be zero. That should be zero. Now, in case of equally likely, in case of equally likely event, and for example, you have other form of lotteries as well. Let's say take another example. To take the same example, let's say z equal to a, b, and c, and again dollar 1,000, dollar 10, and dollar 0. And similarly, take example, let's say p is 1 over 2 and 1 over 2 and 0, and q equal to 1 0 0, and similarly pqr equal to 1 over 3 and 1 over 3 and 1 over 3. Yeah, okay. Now, one decision maker compare the lotteries. Yeah. So what does it mean? If you have to compare these lotteries, so the lottery R has zero dispersion or zero risk, right? So decision maker compares the above lotteries. So lottery R has zero dispersion. Okay, why it is equally likely? And similarly, lottery P, yeah, lottery P and Q have dispersion. Okay. Similarly, lottery P and Q have dispersion. So lottery P and Q has dispersion. And now we will calculate the all lotteries dispersion, and then we will decide which lottery has highest level of dispersion and which lottery has the lowest level of dispersion, and that dispersion will decide to risk for these lotteries. Clear? So now calculate risk or dispersion for each lottery. Yeah. For P, that is equal to 1 over 2, 1 over 2 and 0. So apply that dispersion formula is what? 1 over 2 probability. Clear? And plus minus 1 over 3 number of outcomes A, B, C. Right? 3 number of outcomes. Z was the number of outcomes. So, and then square plus 1 over 2 minus 1 over 3 square plus now the 0 minus 1 over 3 square and calculate that value is what? That is approximately 3 over 18, I think here. Let's check. And similarly for Q1 0 0, so 1 minus 1 over 3 square plus 0 minus 1 over 3 square plus minus 1 over 3 square is That is, I think, 12 over 18. And similarly, 4 r 1 over 3, 1 over 3, 1 over 3. So 1 over 3 minus 1 over 3, 0, 1, 3 minus 1 over 3, 0, plus 1 over 3 minus 1 over 3, 0. So now your answer is 0.
0.17
0.17.
ऊपर ऊपर
0.17. And this one is 3 over 18 divided by 0.17.
Yes.
Okay, and what about what? 0 point
0.7
0.7, and this is 0. So it means that now you can observe that the lottery Q has highest value of dispersion. Clear? So there is highest value of risk in case of lottery Q. Clear? So lottery Q has highest value of dispersion. Lottery Q has highest value of dispersion. So now, on the basis of these, so decision maker decide to prefer or rank these lotteries. Okay, so decision maker so decision maker ranks these lotteries. Yes, A preferred on is what? P, sorry, R preferred on P, and similarly P preferred on Q.
So decision maker ranks these lotteries.
These lotteries are the best one is at least good as P, and P is at least good as Q. That is actually the realization. And now, is that clear? ठीक है. So just take 5 to 6 minute breaks, then we will start and continue. Clear? In further detail of that topic. Yes. Thank you.